Let's look now at how to find the zeros or the x-intercepts of a quadratic function. The function that we'll use is y equals x squared minus 6x plus 8. As usual, let's take a look at the function before we graph it to determine what we already know about it. If we take a look at the first term in standard form, we see that the coefficient a is 1. This means that the parabola opens upward and it is just as narrow or just as wide, depending on your perspective, as the parent function x squared. The last term in standard form is our constant term. Since c equals 8, the y-intercept of this parabola will be located at y equals 8. Now let's go ahead and graph. Hit y equals, then type in x squared minus 6x plus 8, then hit graph. We see that we have a parabola located primarily in quadrants 1 and 4, with x-intercepts located at the positive x values right around x equals 2 and x equals 4. Let's verify those values. We have a couple of ways to do this. Let's start by looking at the table of values. Second, graph. We were expecting to find those zeros or x-intercepts right around the x values 2 and 4, and that's exactly what we find. Using our cursor, notice that when x equals 2, y equals 0. Also, when x equals 4, y equals 0. Those are our two x-intercepts. Using the table of values is one way to find those intercepts. However, there is another way. Let's hit graph again. From the graphing screen, we can hit second, trace, and we can look for the values called the zeros. That's option number 2. Select 2, then enter. The calculator asks for a left boundary. Specifically, we're looking for a point that is to the left of one of the x-intercepts. Let's focus first on this value at x equals 2. I'm going to set my cursor to the left of that value, or above it, then hit enter. Next, the calculator asks for a right boundary. We're going to do the exact same thing, except this time, we're going to move our cursor to the right or below that x-intercept. Hit enter. Last, the calculator asks for a guess. We can move our cursor as close as possible to that x-intercept, then hit enter again. Using the calculate feature, we can find that 0 at x equals 2, y equals 0. Of course, there is another x-intercept. To find it, you'll follow the exact same steps. Hit second, trace, then select option 2, 0. This time, our left boundary is going to be below or to the left of this other x-intercept, the one located at x equals 4. Hit enter, then select the value to the right or above that x-intercept located at x equals 4. Hit enter, and once again, make a guess as near as possible to that intercept and hit enter. The calculator will find the other x-intercept at x equals 4, y equals 0. These are two possible ways of finding the zeros of a quadratic function. Here are a few of the ways that you can express your answer. You can write x equals 2 and x equals 4. Or you can use ordered pairs. 2, 0 and 4, 0. Another alternative is to use set notation. Using curly brackets, we write the list of x values, 2 and 4. Then close the set.